I did like 3 or 4 examples of this in the tutorial. So anybody watching this video, if you want help with number 3, if you look at the videos from this week, which I uploaded last night, you want to look for a video called Calculus Practical Problem. Yeah? Do you know what? Maybe let me just check on the YouTube channel here. Oh, it's stuck.
This is the third time to do this. It has to make update. Must update. Or to delete something.
Yeah.
Or to make a scan if you have files.
I just think it's my processor. You know, the RAM is only 900 megabytes, like 1 gigabyte about.
So you have to delete something.
I only have one program open here, Dropbox. Hang on, youtube.com/maxgrinds.ie. I'll show you the video now. So we'll do the second part with the area. Okay. Videos. Come on. It.
Now we have 134 subscribers.
No, I think it's more. I think it's 140 something. Next one is 200. Okay. Here, this lesson is the one you want. This is where I teach about the practical problems.
And where is the tutorial?
And then the tutorial, you can see in the picture here, this example I did in the tutorial is with a box as well. So the Maths Part 1 tutorial here, or this one here, both of these have some questions on the practical problems. So if you watch these 2 videos after watching this lesson, yeah, I think that should help you. Yeah. Okay, so maybe in the future we'll come back and do this one maybe next week or something.
When in the week of the revision, the week's revision.
I can do it before that if you want. No. You want to do it later? Yeah, okay. Right, so the first part here is to find the normal. And you have this curve and you have the point, and that's enough. Okay, do you want to try that?
Yeah.
And then we'll do the area. So it's y equals 9 minus x squared, and the point is 2, 5. Okay, so let's find the normal.
What is the value of the...
2, 5.
No, for the curve.
9 minus x squared. Do you mean the formula? Y equals 9 minus x squared.
Y minus.
9, oh sorry, here you go.
But the dy minus, dy over dx equals, because I want the m.
Yep.
The m is the dy over dx.
Yep.
And it's minus 2x.
Yep.
So I need the x.
Yep.
It's 2.
Yep.
And the normal.
Yep.
Was it the 2 and 5?
Did I say 2 and 5 or 2 and 6? 2 and 5, yeah. Yeah, 2 and 5, yeah. Yeah, okay. So, you had y equals 9 minus x squared, 2 and 5. Yeah? So dy dx equals minus 2x, which equals minus 4. So the m is 1 over 4. So you have y equals m 1 over 4. Yeah. So you have y equals mx plus c. So 5 equals a half plus c.
Yeah.
So c equals 9 over 2.
4.5.
Yeah. So this should be your answer.
Yes.
Okay, great. Next part is now to find the area. Okay. The area in the picture. Let me just activate this. This area.
It's from 2 and 5.
Well, no, actually, it's from 0 to 3. The 2, 5 is in the middle.
Yeah, but what is in the... Which one minus which one? The curve.
I'll let you decide.
The curve minus.
Or maybe it's not this. Maybe there's no minus. Maybe it's only plus. Try and get an answer, and we'll see if you get it right. How many marks? 6. Interesting. Got an answer? So what did you do in the end? Plus or minus?
For what?
The area.
Minus.
Minus, okay. So, if I just roughly draw this, what you have is this. And we know this point here, it's 3. Okay. And we know this point here, it's 2. Yeah? Yes? So, what you're supposed to do is think of it as this
2 areas.
and this. So you should have area equals 0 to 2. A quarter x plus 9 over 2 plus 2 to 3, 9 minus x squared dx.
But why did you use the 0 to 2 for the line?
I have to, because that's where the line is. So this will be increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Wait for my laptop to catch up.
If you remember in the semester exam, there was a question like this for the area.
Was there?
Yes.
I don't remember. How did you do?
I want to ask if it was this or if it was mine. I did.
Maybe this.
And I got 8 marks.
Not all of them at 8. Most of the 8 maybe, I don't know.
Was a little another way.
Yeah. I'm waiting for it to catch up.
So in the
I think it's because
tomorrow exam test I will do only semester.
that's
I
fine.
already did all semester.
That's fine. That's fine. While that's loading, let's see what answer we should get on the calculator. So the first one was 0 to 1, and what was the function? A quarter x plus 9 over 2. And then the second one, wait, 0 to 1 or 0 to 2? 0 to 2. And then the next one was 2 to 3. Ah. Stop. 2 to 3. Okay. And this one was 9 minus x squared. So this is the answer we should get. Calculating. 73 over 6. Do you want to write that down?
We can do it by section.
True, but it's stuck.
Close it down.
Yes. I need to close some stuff. Close. Close maybe might help.
You're going to use the learn how to be patient.
It's a gift. Patience is important. Oh wait, we're back. Okay, so we'll put 2 in first. 2 squared is 4 over 8 is a half, plus 9 over 2, minus 0. Oh, my mistake. I forgot x here. So if I put in 2, that's a half, plus 9, minus 0, plus 0. Then if I put in 3, I get 27 and 9. Minus. And if I put in 2, I get 18 minus 8 over 3. So that would be 9.5, which is 19 over 2, minus 0 plus 18 minus 18 plus 8 over 3. So this will be over 6, 57, and then plus 16. So that will be, which is what we got.
Yeah.
So we know the answer is definitely right, which is good. 6 marks is good. Let's see what happens next after the area. That's the end of it. Okay. Show that fx has a root between 2.4 and 2.5. Do you remember how to do that? Start. Part 1.
Yeah, you make the y over x, and then you solve it.
No, not as hard as that. Easier. You calculate f 2.4, f 2.5, and you check that one is positive and one is negative.
Yeah, but I also expanded it by the dy over x.
How? Like doing what?
So then dy over x for the x, cubic minus 16.
Yeah. And then what?
It will give you quadratic.
Yeah.
Quadratic.
Oh,
quadratic.
and
if you find the both like.
Yes. But that won't work for this cubic. If one turning point is above the axis and one is below the axis, then it has a root in between. But for this cubic, it has only one turning point, and this turning point is on the... This turning point... Yeah, there's only one turning point. You can't tell doing it this way. You have to do it the other way.
Which way?
This cubic should be positive at 2.4 and negative at 2.5, or the other way. One should be positive, one should be negative. If one is positive and one is negative, it means across the axis in between, is only 2 marks, you see, so it has to be short. Will we do this one?
Yeah.
Yeah, okay. So calculate it for 2.4 and 2.5.
And where can I use my method?
When you have 2 or more turning points.
But how did you know it's only one?
I know from experience that if it's only x cubed and no x or x squared, then it has only one turning point.
So my
Personal experience.
So my ideal work for x cubic minus x squared.
Something like this,
But
yeah.
if it's
Not
like
this
this.
one.
Yeah, it's one negative and one positive.
Good.
And this means it's at 7 points.
Root between. Okay, good. Do you remember the Newton-Raphson formula? Will I write it down?
x0 minus
Yeah, or xn if you want. Xn plus 1.
x0 minus dy over x over fx.
You want to use 1 and 0 or n and n plus 1? So if you use 1 and 0, you get x1 equals x0 minus fx0. Is this what you meant? Over f derivative x0? Yeah. Okay, so they tell you to start at 2.45 and they want you to use the rule once. So they want just once. Okay.
So the x0 is 2.45.
Yeah, is x0.
The f of x is
X cubed minus 15.
Over 3x squared.
Yeah,
That's it.
that's it. And well, put the numbers in for x0. X0 is 2.45. So. Got an answer? What answer did you get?
No, I didn't calculate it for
Okay. Calculate, see what we get. Sounds believable. Let's calculate it here. So we have 2.45, yeah? So it's x0 minus, and then on the top it's fx, so that would be 2.45 cubed minus 15 over 3 times 2.45 squared. So what did you get?
2.47.
2.466. Now it says, does it say anything about significant figures? No, so it'd be 2.47.
Yeah.
Yeah. Okay. Right. Do you remember how to find the inverse?
Equal y minus all.
Okay. So do you want to try this one? Yeah.
Mm-hmm.
So we have y equals e power 5x plus 1. So that means log y equals 5x plus 1. So log y minus 1 equals 5x. So you have this. So the inverse function is log x minus 1 over 5. Easy peasy. Okay, and then FG1, and the F is here. So they want you to calculate FG1.
So
Put 1 in G and
and
into F. Yeah. So maybe we can even do that in our head. 1 in G. So that would be E6. And then E6 goes in here. So that would be E18 minus 15. And so because it says exact form, we must leave the answer like this.
oh, really? Okay.
This means exact.
I would lose mark.
Correct. Okay, do you know how to calculate sine 15? We have to use compound angles. And they tell us this to help us. You can do it?
15 is 16 minus 45. Yeah.
Do you want to try it? No. What about this one? Integrate this.
Yeah, it's okay.
Is okay? Are you sure?
Sine square theta.
Yeah.
We did it yesterday.
Yep.
Yeah, it's okay.
Okay, prove this.
No, of course not.
Try it, and I'll do it. Now, I'll give you a little advice. You have three choices. You can start at the left and try and make it become the right, or start at the right and make it become the left, or start with both and simplify. Wait, before you start,
Which way would you start? Outside of the left?
you could start with the left, but I think it's easier to start with the right. And my tip is usually it's easier to start with the bigger side, which is the right. There's two terms. Not happening. Shall I do it? Okay. Sec theta minus cos theta. Sec theta minus cos theta. Sec is 1 over sine theta. No, it is not. 1 over cos theta. Minus cos theta over 1. Which is cos theta 1 minus cos squared theta. Now, if you look at what you're trying to get to, you need to get a sec down here. You need to get tan up here. Tan is sine over cos, and sec is 1 over cos. So I feel like on the top I should change 1 into sine squared plus cos squared minus cos squared.
So it should be sine squared.
So it'll be sine squared. So you get sine squared theta over cos theta. Now if I want to make this a tan, which is what I want on the top, I need now to, well, let me write again, divide the top and the bottom by cos squared, because this will become tan squared theta, and then this will cancel the square to make 1 over cos, and 1 over cos end of proof.
I made until sine squared theta over cosine.
Good, you got to here. You just, one step left.
Really sure.
Huh?
Finish.
Yeah, is this the end of the question? Can I go back? So, let me just see. That's the end of that. B5 is vectors. You like or don't like vectors? Part B is implicit derivatives.
It's okay.
And then the exam finishes. Number 6 is, hang on. No, number 6 is integration and volume and ODEs and partial fractions.
So it's okay.
Well, difficult, but it's okay. Strange, no probability question this year. There should be one. Wait, tomorrow morning we have class at 9. This is when I'll give you the test. It might just be us, or might be more. Are you going to give me the test, or are you going to keep it? You don't know yet.
Yeah, because we have tomorrow the first draft of chemistry.
What time? Like you must give,
In class.
which is at what time? In the morning
No,
or after
after
lunch?
your class. But
Straight after my class.
Yeah, but it's not the problem here. For today, I wrote only yesterday 300 words.
How many words do you need?
1,500.
Oh,
So I need it for today. I need like 200 or 400 to make it a good draft, and in the second draft, if I double it, it will be 1,020. So it will be okay. But the last said I might extend the date. So if it extend the date, I will study math and I will give you the.
but if not,
If not,
I understand. Okay, well, we'll see tomorrow. Do we have class after lunch? Physics?
Yeah.
Yeah, okay, so I'll see you in physics later then. And maybe I'll see the other students.